Hello, welcome everyone to this tutorial. Here we have some special questions in logarithms to solve. The first one we have log of 64 to the base x minus 2 is equal to 2. Then the second we have the natural log of e to the power x squared minus 5 ln e to the x plus 6 is equal to 0. And then the third exponential equation, we have e to the power 3x minus 3e to the x minus 4e to the negative x. Okay, let's dive straight away with the first equation. All right, this one, we carry out what we know already from previous tutorials. This base raised to that power will give us the argument. So we write it out. So it means we have x minus 2, the base, raised to the power 2 should give us 64. All right. Now, this is already in index form now. We can change 64 to index form of the same power. 64 is the same as 8 squared. And so we have x minus 2 squared is equal to 8 squared. At this point, we have this index expression equals to this index expression. If that equality is true, then it should be true also with the powers and with the base. We check the powers. 2, 2, all right? The powers are equal. Therefore, we expect the base to also be equal. This therefore means that we expect x minus 2 to be equal to 8. Okay? So that we will now take negative 2 that way, and we'll have x is equal to 8 plus 2, and so x is 10. All right? So the solution of the first equation is x equals to 10. As simple as that. Now let's look at the second equation. We have natural log of e to the x squared minus 5, natural log of e to the x plus 6 equals to 0. Now we'll use the law of indices or of logarithm, which says a natural log or log of, this is, pay attention, ln x is the same as log to the base e of x. And so um, ln, the law of logarithm, which says log to the base a of b raised to the c, pay attention, raised to the of a raised to the b is equal to b. That law is the law we're going to use here. Okay, and so for example, ln e x squared is the same as log to the base e to the x squared. And so if we follow this law, that should give us x squared. And so we'll carry out the same analysis here. This one will give us x. Okay. All right. So let's now dive in now to the equation. We have applied the laws, so now let's get into the equation. So this one now becomes x squared minus 5x plus 6 is equal to 0. Okay, all of this just gives us this. We end up solving this quadratic equation. And so we're going to look for factors of 6 whose sum is negative 5. Okay, this one is very easy. So the two factors of 6 whose sum is negative 5 and whose product is 6, they are negative 2 and negative 3. So we have x minus 2, we have x plus 3 is equal to 0. Because if we multiply this out, you're going to get that quadratic expression up there. Hey, pay attention, please. Minus 3. All right. If you multiply this out, you're going to get that expression over there. Now, if this product is equal to 0, means either x minus 2 is equal to 0, which therefore means that x is equal to 2, or x minus 3 is equal to 0, which therefore means that x is equal to 3. So these are the two values of x for that equation. So simple as that. Now we look at the third equation. It is 3e to the 3x minus 3e to the x minus 4e to the negative x. All right, so we don't want negative powers, so this one can be handled by applying the law of reciprocals. This is the same as e to the 3x minus 3e to the x minus 4 all over e to the x is equal to 0. To do away with this denominator, we multiply all through by e to the x. So we have e to the x into e to the 3x minus 3 e to the x minus 4 minus e to the x into 4 all over e to the x is equal to e to the x multiplied to 0. So what we have done is to multiply each of these with e to the x, this denominator, so that we now apply our laws of indices. The base is e, so we add the powers. This becomes e to the 4x, x plus 3x. This is the same as 1x plus 3 of it, we have 4. Then minus 3, 1x gives us 2x, e to the 2x. Then coming here, this e to the x cancels with that e to the x. So we're left with negative 4. And then, of course, anything multiplied to 0 is 0. Okay? Now, looking at this carefully, we will realize that it is actually a quadratic equation in terms of e to the x. In terms of e to the 2x, please. All right? If you look at this carefully, it can be written as e to the 2x squared, this one, going over there, minus 3e to the 2x, then minus 4 is equal to 0. Okay? So if we make the transformation y equals e to the 2x, then this will become, let us clear over there and continue with our solution. If we make this transformation, then this equation will become, wherever we see e to the 2x, we put y. This becomes y squared minus 3y minus 4 equals 0. So this is actually quadratic that I've been hiding. Okay, equation was actually set as if it was an exponential equation, but in our reasoning, in our process of solving, we realize that it's actually a quadratic set in another form. That's why we call it special equations on logarithms. So this is a quadratic that we have to solve. We look for two factors of negative 4 whose sum will give us negative 3. Okay, so those two factors are negative 4 and positive 1. And so this becomes y minus 4, y plus 1, giving us 0. If you multiply out this, if you open out this bracket, you are going to get back that quadratic equation. You should always verify to be sure that your factorization process is correct. Okay, now we have once more the product of two things giving us 0. So either y minus 4 is 0, in which case y is equal to 4, or y plus 1 is 0, which gives us y is equal to negative 1. We were not asked to solve for y. There was no y in our question. We asked to solve for x. So we have to come back to this substitution, to this transformation that we did to be able to solve for x. This is the relation between y and x. This is the relation between y and x. And so we say, but y equals e to the 2x. So we'll be slotting in each of these values in the place of y in order to solve for the corresponding x. So we say when y is 4, that means we'll now we'll come and put 4 here. That means 4 equals e to the 2x. Okay? That means 4 equals e to the 2x. Now, how do we get the 2x? How do we get the x? How do we get the x? We have to carry out ln, natural logs of both sides. If we take ln of both sides, we have ln 4 is equal to ln e to the 2x. When we apply the laws of logarithm, the power will come in front. So we have ln 4 is equal to 2x ln e. But we know that ln e is simply, we know that ln e we know that ln e is log base e of e, which we expect to give us 1. Okay? So this will be 1. So we now have ln 4 is equal to 2x. Alright? So to get our x finally, we divide both sides by 2. So that we have x is equal to ln 4 all over 2. Pay attention, there's no possibility to cancel here. You don't come and say 2, 1, 2, there, 2. This is ln of 4. It's the natural log of 4. It is not 4. So this is the first value. So we have x is equal to ln 4 all over 2. Now we take the second value of y. When y is equal to negative 1, okay, we'll come and put it again here. We'll come and put it again there to get our corresponding value of x. When y is equal to negative 1, we say negative 1 is equal to e to the 2x. Okay? Now, pay attention, look at this. We have an exponential expression giving us a negative value, which is impossible. No exponential expression will give us a negative value. This one is simply impossible. If we go ahead to take ln of both sides like we did here, then we'll end up looking for ln of negative 1, which does not exist. Ln of negative 1 does not exist. So this case is simply impossible. Okay? Therefore, the only solution to that third equation is x equals ln 4 all over 2.